Good afternoon, and thank you for joining us. I'm Robert Baylor, Director of Communications at NUCA. Welcome to our latest Webinar Wednesday, sponsored by NUCA National Partner Komatsu. Today's webinar will be recorded, and a copy of the recording will be provided to all registrants and attendees. It will also be available in the next few days on NUCA's YouTube channel, which can be accessed via our webinar's webpage at nuca.com. First, before we begin, some webinar housekeeping. If you haven't done so, go ahead and click on the two blue circles in the webinar personal meeting controls at the bottom of the viewing area. One is the participant list, which allows you to see who else is attending the webinar, and the other is the chat feature. You can chat amongst each other, or you can send the host messages. Please be respectful. Some of you may have noticed that the exact meeting controls at the bottom of your screen may be different. WebEx seems to be updating the software today, and of course, it didn't tell us before we prepared our slides. All participants are muted upon entry. Phone participants, and there are a number of you, can use *6 to mute yourself. Questions will be asked at the end of the webinar. To ask a question, you can submit a written question at any time using the chat feature, and I will read those written questions to our presenters at the conclusion of the presentation. Or you can hold your question until the end of the presentation and unmute yourself to ask the question. Please remember to mute yourself again when you're finished asking your question. Now let's get started. Today's Webinar Wednesday, next slide. Today's Webinar Wednesday, generously sponsored and presented by NUCA National Partner Komatsu, is about what small changes you can make on your job site that will reap big rewards. Our expert presenter today is Matt Benlich, Director of Business Solutions Group at Komatsu America. Matt has been with Komatsu for 18 years. His present team provides consultation on production, owning and operating costs, and telematics for the Komatsu construction machines operating in the North American market. He has an MBA from Northwestern University and a bachelor's degree in engineering from the University of Illinois. Thanks so much for joining us today, Matt. I turn the webinar over to you.
Great. Thank you, Bob. Can you hear me?
I can.
Very good. All right. Well, good afternoon, everyone. And thank you so much for joining this NUCA webinar. As members of the NUCA group, National Utility Contractors Association, I assume that you guys are probably already familiar with Komatsu and our equipment. But if not, our talk today, and like Bob said, it should go 20 to 30 minutes, should serve as an introduction, but more importantly, I hope you find it interesting and educational as well. So again, I'm Matt Beinlich, Director of the Komatsu Business Solutions Group, and our scope of work covers three main areas. We perform fleet recommendations for customers. We talk to customers about total cost of ownership of our equipment. And then we help customers use the telematics system or Comtrax on our machines to gain insight in how they might operate their business more efficiently. Let's go back to fleet recommendations for a minute here. When I say fleet recommendations, I'm talking about identifying the right machines or machines for your particular job from a production or a fit for task perspective. Going to total cost of ownership, what I mean by that is that our work is meant to give end users clear, firm numbers for fuel, maintenance, and repair based on their particular equipment ownership strategy and term. And then finally, by telematics-based insights, I mean that we study nationwide and individual machine operational and health data to help customers benchmark the most important bits of information and look for opportunities to improve efficiency. Excuse me, just gotta skip to the next slide here. Little technical difficulties. There we go. Okay, you still with me, Bob?
I am, Matt. I am. Go on. I'm eager to learn.
Very good. All right, so that's good to hear because I've teed up a few mini case studies in each of these areas, specifically for the size and the type of equipment that NUCA members run. But you should be able to apply the concepts to either smaller equipment or larger equipment or even different types of equipment that you have in your fleet. Now, the subject of my webinar is what small changes can you make at your job site that reap big rewards? And small and big, these are really very subjective terms. So what I'm going to do is quantify everything to help you dial that in a little bit better. In each of these case studies, I'm going to get specific enough to show you that efficiency improvements are both possible and worth pursuing. And to settle any concerns you might have about my numbers, here are the assumptions used throughout all three cases. Let's take a look at them real quick. When I reference fuel costs, I'm going to be using fuel at $3 per gallon. When it comes to DEF, I price that at $5 per gallon. And then if you think of the market, I'm talking about United States pricing of machines, maintenance, and repair using a couple of programs that are available from Komatsu to contract for a fixed cost per hour. I'm looking at a 5-year, 10,000 hour ownership term. And remember, although I'm using Komatsu models in my examples because that allows me to give you hard numbers, I really encourage you, don't get too hung up on the particular models and instead think of applying the principles that we're going to discuss to your fleet, regardless of the brand or the type of gear that it includes. And as a side note, I want to say that you should be able to get these types of numbers from any manufacturer, but always, always, always ask about their assumptions like I'm showing you here. Those numbers, those assumptions can make a big difference. And if you want to do an apples to apples comparison between brands, then the assumptions, those need to be the same. All right, let's jump right into our first scenario. Scenario 1 is right sizing with excavators. Our first scenario takes a look at the differences in owning and operating costs between two adjacent size class machines, the PC360 and the PC490. So just to give you a feel for the size of these machines, right, because you may be running other brands, or maybe you want to know the numbers that I'm going to show you, are they for models that are bigger or smaller than you typically run. The PC360, well, that's a 36-ton excavator, and it has 257 horsepower. The PC490, that's a 50-ton machine, and it runs 359 horsepower from its engines. You see these machines everywhere. You see them on the side of the road doing contracting work, highway work. You'll see them in subdivisions, the type of jobs that I imagine NUCA members go after and bid. But what I know from my time traveling around is that these machines are rarely pushed to their operational limit. So whether you determine the right size machine based on bucket capacity, maybe dig depth or lifting ability, or something else entirely, it's pretty simple to compare specs and look for an opportunity to drop a size class based on your particular job's needs. And that's what we're going to look at here. I'm going to give you an example of a job that I imagine NUCA contractors pursue every day. Let's say that your job requires you to be able to dig a flat bottom trench up to 10 feet deep and set loads of up to 20,000 pounds at that same depth with a reach of 20 feet. We want to know, can a PC490 do it? Well, I'm going to suggest that there's a handful of things that we need to check to be sure. And the places to go for this, again, regardless of the brand or the type of equipment, are going to be the brochures or the spec sheets. That's going to give you information on things like working ranges off here on the left. And it's going to give you information on like a machine's liftability or its flow or other things that you may measure a machine's capabilities by. If you're talking excavators, it's really important to remember to specify both the boom and the arm length of the particular configuration. Most excavators are going to have multiple work equipment options. And then you also have to remember to specify both the undercarriage width and whether you're going to be lifting the load over the front of the machine or over the side. That's going to make a dramatic difference on whether a machine is capable of doing your job or not. You know, if this all looks a little bit intimidating, and we'll go through it a little bit more carefully, I want to encourage you, reach out to your distributor or your manufacturer, regardless of the brand, because they are going to be able to help you interpret this information correctly. So let's see, can the PC490 do this job? Can it dig a 10-foot flat bottom trench, set loads of 20,000 pounds at that same depth, out 20 feet in front of it? The first thing we're going to do is we're going to look at dimension E here, which is the max digging depth for an 8-foot level bottom. And it says that with our 11-foot 1-inch arm, we can do that down to 25 feet below ground level. So we're looking at dimension E here. So check on that part. Now, the next part of our requirement was, can we hold a 20,000 pound structure, maybe a trench box or something like that, out 20 feet from the center of the machine and drop it down to 10 feet below the ground level? So here, we're going to come dimension B down to 10 feet, and then we're going to go across until we get to 20 feet from the center of the machine. Again, we're going to be holding this over the front of the excavator, not over the side, and we find that this machine has a capacity to hold 38,500, so substantially more than the 20,000 pound target we have. And that's a really good sign that there you may have a chance to drop down a size class, or maybe even more. So before we look at some other options here, I want to familiarize you with the way that we visualize cost per hour for customers. We like to keep things really simple. Remember those assumptions that I had mentioned earlier on: fuel at $3 a gallon, DEF at $5 a gallon, maintenance and repair for 5-year, 10,000 hours through the manufacturer. Well, the first part of owning an operating cost, and usually the largest, is going to be the machine itself. And when I talk about it in cost per hour terms, I'm depreciating that machine fully over the course of 10,000 hours. Followed quickly by fuel. Fuel is a major operating expense, as all NUCA members know. That's why we want to make sure that you have easy access to good quality fuel information from us. DEF doesn't make a big difference, right? And repair and maintenance oftentimes are a lot smaller than customers might think. But we're looking at about 65 bucks an hour for this size class machine based on machine, fuel, DEF, maintenance, and repair. And we're going to see if we can get that down a little bit. Okay, so let's take a look at the size class smaller, which is the PC360. Right, that's our 257 horsepower machine. I have gone ahead and done the work and looked at the spec sheet. I've looked at the lift charts and the working ranges, and I've confirmed that for that job, the PC490 is actually overkill. I mean, a lot of people will use that size machine for that type of a job, but the PC360, it can do it. And you know what? It can do it at 25% less per hour than the bigger machine. That's like 15 bucks an hour that you're going to save over the course of a 10-hour day. Right, that can really add up to some substantial savings. And if you really think that you can keep the machine that you're going to be putting into that application within that working range, within that envelope, actually an even smaller machine, the PC290, can do that job, right? And then you're saving 40% on a per hour basis versus the bigger machine that you might have considered putting on the job. What I'm arguing here is that considering that type of a cost savings, easily 20% by dropping a size class, it makes a lot of sense to go ahead and ask whether you could be running larger machines than are absolutely necessary on your jobs. And again, don't think this is just about excavators. You can apply the same process or concept to trucks, graders, drills, any type of machine where there's various size classes to choose between. So that's one of my favorite examples, right sizing, because again, from my time in the field, it's convinced me that plenty of end users are running larger machines than they actually need. But for those of you who maybe have a centralized fleet management group with estimators pushing back on the project managers and making sure you're not putting bigger machines out on a job that are absolutely necessary, I have another case study for you. And this is going to be a topic that I think you're probably familiar with. We're going to talk a little bit about managing idle time. Again, I want to be maybe as specific as possible, more specific than the articles that you have read in the past. And to quantify those savings, I've got to start by picking a model. So what I'm going to be working through here for my numbers is a WA320. That's about a 3.5-yard loader with 165 horsepower, just for reference purposes. Okay, so we know from Comtrax, I mentioned our telematics system, that in North America, this model, mid-size wheel loader, runs on average 967 hours per year. It's a lot of data on this chart, and we're going to go into it in a little bit here. Of that 967 hours per year that the average machine is utilized, it idles 40% of the time, and it's burning 2.1 gallons per hour. So how do I know that? Well, every one of these blue dots in the graph here, that is one of our machines out in the field, and it's data from 2019, the last complete year. How many hours did it run? How much fuel did it burn? What was its idle ratio? You can see there's over 1,500 of these machines in the field, and that means we have a really good idea of what these things are going to burn, especially based on their idle ratio. So let's take a closer look at the graph. We've got fuel consumption, or gallons per hour, going up and down. And then from left to right, you see the idle ratio, the percentage of the time that the machine just has its engine at idle and is not doing any work. You can see there's a really strong relationship between those two factors. Every one of those blue dots ends up clustering pretty darn close to the trend line. So if we're looking at going from, let's say, the national average of 40% idle down to 30% idle, because chances are you're probably not the best run fleet in the United States. I'm sure you're close, but maybe not the best. Most of us are average. Is that going to be possible? Do we think we could get down from 40% idle to 30% for this machine? The good news is I know that it's possible, because let's come back over here to the right again. The average of all those machines is 40%. The 75th percentile, or 1 in 4 customers running this machine, they achieve 31% idle. So this is totally possible. 1 in 4 of our customers are already doing that. And that's going to be the scenario that we're going to examine. I'm going to suggest that managing your idle ratio down from 40% to 30% is going to be worth your while. People always talk about annual fuel savings related to idle reduction programs, and yeah, that's part of the equation, but it's far from the entire story. Machines really don't burn that much fuel at idle. I studied the data on the WA320, and for that model, it's about a half a gallon per hour of fuel that's being burned if the machine sits at idle. So that savings is going to add up to 50 gallons or maybe $150 per year based on this machine's utilization. Where the savings really start to stack up is when you account for things like the machine depreciation, maintenance, and repair over the lifetime of the machine. So now I'm going to project out from 1 year to the full ownership period, and I'm going to ask that we use a 10-year ownership period for this machine with that average annual utilization, again, of 967 hours. So over the life of the machine, reducing your idle ratio down from 40 to 30%, well, that's going to save you about $3,000 in maintenance, unnecessary maintenances that you're doing if you're idling, $2,000 fewer in repairs, and here's the big one, nearly $12,000 in depreciation can be saved if you reduce your idle from 40 to 30%. And that's because you're going to be taking a machine with lower hours to the used equipment market. It's going to value it higher. If you add to that the fuel and the DEF savings that we talked about before, we're talking about a total of about $23,000. This should be a dollar sign, not a percent sign, excuse me, $23,000 that you can save by managing this machine's idle time throughout its entire life cycle. The key takeaway here is that your payback on managing really comes in the form of fewer total machine hours. We're stretching its warranty, we're making sure it's doing more productive work between maintenances, and it's going to leave you with a machine that's worth more again on that used equipment market because it's got fewer total hours. $23,000 worth of savings on a 3.5-yard loader by cutting your idle 10%. I think that's a savings that's worth pursuing. And remember, this same concept is going to apply to any piece of equipment that you own that's got an hour meter or an odometer on it. All right, we're moving into our third case study here, and we are going to talk about maximizing versatility with bulldozers. So for the third case study, we're going to look at 3 what I consider to be mid-size bulldozer models and some factors that might influence your decision on which is going to be the right one for your next job. Smaller dozers are often going to be doing finished grade work that a larger dozer is just too big to handle, and very large dozers, well, they're all about providing maximum production. It's these mid-sized dozers that I've got here, and you can see their operating weights, where I think NUCA members may have to perform a balancing act and get creative to make sure that the job gets done, but the owning and operating costs aren't excessive and don't blow your budget. Again, just for frame of reference, these are the size machines we're talking about. They range from 50,000 to 90,000 pounds. And we're going to start by thinking about the weight, right? That actually is pretty important when it comes to bulldozers. Their drawbar pull is going to be based on their weight. It also has a lot to do with what it's going to cost to ship these machines and mobilize them out to your jobs. Bigger machines, well, they're going to be more expensive to ship because they may require a larger trailer or a different type of trailer. And depending on your state, maybe even some different transportation permits may vary from one model to the next larger. So think about that. Even before you fire up the engine in your bulldozer, mobilizing a larger machine than is absolutely necessary can start to drain your project's budgets. And since we're talking about operating weight, I think we should also consider ground pressure. This is really key when we're thinking about how to properly apply bulldozers to a job. I'm guessing that utility contractors are most likely going to be running low ground pressure spec machines, but the bigger models still have higher ground pressure than the smaller ones. Right? All these machines are considered low ground pressure by us, by our competitors that have similar sized dozers, and you can see what they are here. And you can see even a low ground pressure big machine is going to have higher ground pressure than its smaller brothers and sisters. So these 3 dozers, they range from 5 pounds per square inch to 9 pounds per square inch. And you can imagine a situation where the D65 and the D85, based on these data points here, they may have adequate flotation for your job's underfoot condition, where the D155 may just not be light enough on its feet to stay afloat at 8.7 feet. It may sink. Now, I don't want to suggest that getting the lowest ground pressure should be your only goal, though, because actually excessively wide tracks can have their own drawbacks. If you've got a rocky underfoot condition, and an uneven surface, then you're probably going to want to have more narrow shoes. If you run really wide pads on rocky, uneven surfaces, you may find that that can cause damage to the track pads. It can also put higher bending loads on other undercarriage components. You can see here, right, that the narrow track options, they'll have incrementally higher ground pressure. If your underfoot condition can support it, then you want to run a narrower track if possible. So all these dozers, the D65, D85, D155, these models can push some serious material when they need to, but just how much you need to be capable of moving is going to influence which is the right size class for you. Let's imagine a scenario here where you need to move 400 cubic yards per hour. This should be something that NUCA members are used to doing in site development type applications. Again, it's important that we talk a little bit about our assumptions here. So what I've got is a job efficiency of 83%, and that means that 50 minutes per hour is going to be meant doing productive pushing type work. That means we're not simulating best case scenario numbers for you. We're showing you real world numbers that account for some of the unexpected delays that happen on a job site. I'm also putting in a blade factor of 100%. So that means either we've got really talented operators who know how to keep the blades full, or maybe it's a newer model that has machine control and can ensure that we're going to get nice full blades. What I'd like to draw your attention to here is just how much more productive these machines are on short pushes. Let's go over the graph again. Cubic yards per hour, that's the production rate on the up and down axis. And then from left to right on the horizontal, we've got the push distance, how far we've got to move the material. You'll notice that regardless of the size bulldozer we're talking about, if we can keep those pushes shorter, the machines are going to be dramatically more productive than if the pushes are really, really long. So now let's think of our 400 cubic yard per hour production target. And let's say that the way we've got our job site set up, we can keep our pushes from like 90 to 100 feet. And that's considered a pretty efficient push. You're going to be able to achieve your production target of 400 cubic yards per hour with the D65. But sometimes that's not possible depending on the way your site is laid out. Maybe you just have to push further. Maybe you've got to push 170 feet. What size machine are you going to need to hit that 400 cubic yard per hour production target? Well, you're going to have to step up to the D155. Now that machine is going to be more expensive to own and operate, but if you cannot rearrange your application to get those pushes down, that's going to be the machine size class that you need to run. And then of course, if your pushes are somewhere in the middle, you may find that you can get away with the D85. So what I want to say, just to reiterate here, is taking a hard look at how the job is set up in terms of push distances and the required production rate. That's going to help you zero in on the preferred dozer size class. And now let's think about other types of gear, non-bulldozers. They may have production measured differently, and that's just fine. The key is to ask yourself what production is needed, and how can you optimize your application, and whether that might enable you to run a different model than you originally expected. If we are talking bulldozers, though, aside from ground pressure, required production, another factor that you will want to consider, and a reason to consider dropping down a size class, is you may find that the machines are a little bit more versatile in this D65 size class. You may have different blade type options, rippers, intelligent machine control, etc. Specifically with the blades, the D65, that's the first size class where we offer power angle tilt blades, and these 6-way blades are going to allow you to do more different types of work on your job as opposed to bigger machines that are really just meant to do production type pushing. I know NUCA members understand that keeping equipment utilization high is the most important thing you can do when it comes to managing your fleet. And we know from contracts that as machines get bigger, so does their annual utilization. If that extra versatility of the smaller machine helps you beat the national averages, then there's a really good chance that you're making more efficient use of your machines than your competitors, meaning you're doing your job more effectively, and that should help your bottom line. But just remember, like we learned in the wheel loader example, those idle hours don't count. In fact, they're really a drain on your budget. Just reflecting back again on some of the research I did leading up to this webinar and thinking of the industries that NUCA members participate in, excavation, water and gas, site preparation. I hope that at least one of these cases resonated with you, but even if you're not typically running excavators, wheel loaders, or bulldozers, you should be able to apply the concept of right sizing, idle management, and versatility to any type of equipment that you do run. And with that, Bob, I'm glad to take a few questions and let people get back to their afternoon.
Thank you, Matt. This is the time for participants to either ask, send me a question via chat, or you can always ask it yourself as well too. I do have one question that was submitted, Matt. It is. One of your examples had cost per hour. How can I convert this into cost per cubic yard?
Cost per hour to cost per cubic yard. That is a great question because a lot of contractors, the way they keep score, the way they manage their jobs is tracking cost per cubic yard. So to go from cost per hour, I'm just doing some math here. If we've got cost per hour, like we had seen on a couple of my earlier slides, and you want to go to cost per cubic yard, well, that means you need a production figure. You also need cubic yards per hour. And if you do the math, the way it works out is cost per hour divided by cost per hour divided by cubic yard per hour. That is how you get to cost per cubic yard. You need both a cost and a production figure. When you combine them, you're going to get cost per cubic yard. Good question.
Thank you, Matt. And let me get into the chat. We have another one. During the idle management example, it looked like fuel consumption was lower when idle ratio was higher. What's going on there?
Good question. Let me bounce back to that slide so people can take a look at this. So yes, these are inversely related. Fuel consumption goes up as idle ratio goes down, or as idle ratio goes up, fuel consumption comes down. And in general, we were saying we want to burn less fuel, right? But that doesn't mean that we just should idle more because those idle hours are totally wasted. They're not productive. So what I want you guys to do is think of that idle time as time when really, ideally, we have the engines shut off. Maybe you use some of the new technology that's available, auto idle shutdown or turbo timers, to make sure that the machines aren't just sitting there wasting fuel running up the hour meter reading. Higher fuel consumption, if you're getting more work done, that can be a good thing. It's not bad to be up here. These are the customers that are actually getting the most production out of their machines. Personally, if it was me, I would rather be up here than down here. Good question.
Thank you, Matt. Are there any other questions from the audience? You can either do what you've been doing, sending them to me personally, Nuka host. You can always jump in. It looks like I've got one last one here, Matt. Your maintenance and repair costs look low. Can you provide more details about what goes into them?
Yeah, that's a fair question. So let me go back to a slide that had maintenance and repair costs. Here, we'll take a look at the excavator stack up based on size class. Okay, so if these look low to people that are out on the webinar, there are some things that are not in here. For example, undercarriage is not in my model. The reason I don't include it in these figures is because it really varies a lot depending on application. I don't think that we can speak with a broad brush on what excavator undercarriage cost per hour is without knowing more about the machine's application. The key takeaway, though, right, is that although the undercarriage is not in here, or something like the operator, where you'd be paying him the same amount regardless of the machine that he or she is running, if you can drop a size class, any of those expenses like operator, like tires, if we're talking wheeled machines, they're going to drop accordingly with the smaller machines. So it's not that the main lesson doesn't apply. It still does make sense to look for opportunities to right size or drop a size class. All the other costs that maybe weren't included here, those should come down accordingly with the size class machine.
Thank you, Matt. We have another question. Is there a truth that equipment should not be shut down due to maintenance issues developing rather than leaving it running during idle time?
Interesting. Well, of course, I can only speak for Komatsu. My background before I was in this role was in our technical support and product quality group. And I can tell you that our Tier 4 final engines, they prefer to be worked hard. And so to get around that and make sure that idle doesn't do damage to the machines, right? Because sometimes machines do need to idle. The control systems now are smart enough to figure out how to raise engine RPM, and make sure that the after treatment devices still get the heat that they need to function properly. Also, we've got something called auto idle shutdown that will make sure that the machine is safely shut down if it's idled after a certain period of time, and protect the after treatment and the engine. So, there is some truth to newer engines not liking to idle, but I also want to say for some manufacturers, the control systems have caught up with that and can kind of manage the situation for operators.
Thank you, Matt. That was very interesting. I have an old British sports car that doesn't like to idle. All right, there doesn't appear to be any more questions, and we're at the half an hour mark. Let's go ahead and wrap this up. Matt, thank you very much for your time today to present this information to our guests. We'd also like to thank Komatsu America for their kind support of NUCA and our educational webinar series. Today's webinar will be recorded, and a copy of the recording will be provided to all registrants and attendees. A recording of this webinar will also be available on the nuca.com website and on our YouTube channel. And thank you for your time today to join us for Webinar Wednesday and for supporting NUCA. Our next NUCA Webinar Wednesday will be held October 7th at 2 p.m. Eastern. Thank you for your time this afternoon, and please enjoy the rest of your week.